Hi, I'm Maribel Lopez, the founder of Lopez Research, and I'm really excited to be here today to talk to such a great group of people that are very diverse in terms of what they're doing in the AI ecosystem. So, without further ado, I'm going to ask each of the panelists to introduce themselves and what their role is in the AI landscape and what they're doing that we would consider exciting. So, why don't we kick off with Jimmy?
Hello, Maribel. My name is Jimmy Nassif, and I'm the head of IT planning system at BMW Group Logistics. I'm an IT manager and IoT expert at BMW Group with almost 10 years of experience in automotive engineering. Since 2016, I'm leading an AI and digitization lab in BMW Group Logistics division, leveraging innovative solution in field of IoT and solving real-world problems in distribution and manufacturing.
Brilliant. Matt?
Hi everyone. So my name is Matt Scott. I am the CEO and co-founder of Malong Technologies. We are an AI computer vision startup. That's an Accenture-backed company. Most of us are hailing from Microsoft Research, and we focus on the retail industry, and we solve high-value business problems for in-store shopping.
Jered, up to you.
Hi, I'm Jered Floyd. I'm a technology strategist at the Office of the CTO at Red Hat. And I'm working on technology strategy around edge computing, so edge computing architectures, and particularly how AI ML techniques are used at the edge to drive new business cases and applications.
Excellent. Okay, so let's jump right in. Jimmy, BMW, they do a wide range of things in AI, everything from working on autonomous driving to robotics. So in your field, you've been with BMW for a while. Robotics isn't a new thing for you, but I thought perhaps you could tell us a little bit about what's changed and how your work with AI has changed over the past year and a half.
Yes. So BMW Group is increasingly relying on innovation from the field of digitalization and Industry 4.0 in production logistics. So this will ensure the company's global production network to continue to receive the parts it needs in a timely and reliable manner in the future. And basically, just to give you an overview how BMW functions, I don't know how many of you already visited a plant at BMW, but every 56 seconds we produce a car just in time and just in sequence, which make it a little bit more complex. And just to count some numbers, the BMW's group supply chain takes millions of parts flowing into a factory from more than 4,500 supplier sites, involving 230,000 unique parts number, and in growing volume as BMW Group car sales have doubled over the past 10 years to 2.5 million cars sold in 2019. Moreover, as I already said, BMW Group vehicles are produced in less than 1 minute and offered to customers with an average of 100 different options, resulting in 99% of customer orders being uniquely different to each other. So this creates an immense challenge for factory logistics. And ultimately, the sheer of volume of possible configuration became a challenge of the BMW Group production in three fundamental areas: the computing, logistic planning, and data analysis. So this gives us the opportunity now with new technology and new innovation to optimize these processes and make it easier for our people in the production and in the logistics. And as a response on these challenges, we use NVIDIA's Isaac robotic platform to develop 5 different AI-enabled robots to improve the logistic workflow, powered by a variety of NVIDIA Jetson AGX, Xavier, and EGX edge computers. These includes both navigation robots to transport material autonomously, as well as manipulation robots to select and organize parts. So everything is developed, as I said, on NVIDIA Isaac SDK. The robots utilize several powerful deep neural networks addressing perception, segmentation, pose estimation, and human pose estimation to perceive their environment, detect objects, navigate autonomously, and move objects. These robots are trained both on real and synthetic data using NVIDIA GPU to render ray traced machine parts in a variety of lighting and occlusion conditions to augment real data. So the real and the synthetic data are then used to train deep neural networks on NVIDIA DGX systems, and the robots are then continuously tested in NVIDIA Isaac simulators for both navigation and manipulation, operating on NVIDIA's Omniverse platform, where multiple BMW Group personnel in different geographic locations can all work in one simulated environment.
Okay, so we're going to circle back to some of the challenges that you had and some of the opportunities that you see moving in AI, like basically some of the how you just mentioned, but what you might think is next, what you need to do next. I want to head to Jered because Jimmy just talked to us about a very advanced use case with AI in terms of doing robotics. Jered, I know that you at Red Hat definitely work with a lot of different organizations. Automotive is one of them, but perhaps you could give us some other perspectives of how you see people using AI.
Yeah, absolutely. I think one of the really cool things we do is, as a platform company, we work across industries. We provide platforms, both operating system and container orchestration platforms, and work with upstream open source communities to be able to pull in the best of breed components. So we have support upstream and in collaboration with NVIDIA for GPU accelerators for AI workloads. And then we work across multiple different verticals on how different edge architectures can be deployed. These could be distributed clusters, distributed compute nodes that are part of a central cluster, or standalone IoT type devices. So certainly we work in manufacturing, work in automotive, but I think one of the really interesting use cases that we keep coming across are smart city use cases or connected camera use cases. This really leverages the benefits of driving AI to the edge, because you have video streams, you may have hundreds, you may have thousands, tens of thousands of video streams. It's not practical to bring all those video streams back to a central location. That you can't, for bandwidth reasons, for latency reasons, for cost reasons, do that. One partner that I've been working with has fleets of connected cameras, and they use these connected cameras for all sorts of city enablement, traffic monitoring, accident detection, hazard detection, map refinement that feeds into automotive use cases such as autonomous driving. And it's not realistic to take all that data and process it directly on these low-cost cameras, for example. And it's also not realistic to push that all the way back to a core data center in a public cloud or private cloud. So instead, they're able to make use of edge enablement, edge compute clusters that have GPU acceleration, for example, to do that video analytics. And that means that 5G network infrastructure is becoming increasingly critical to this, that instead of just having cameras that are wired into a network, wired into an infrastructure, you now have these wirelessly connected cameras that take advantage of the massive increase in bandwidth, reductions in latency, and greater device density that 5G networks provide to be able to offload that AI analytics, that video analytics, to edge compute locations. So smart cities, smart camera use cases are really cool. And I think another one that's really fun to talk about that I can call out is there's a project called the Mayflower Autonomous Ship, which is an IBM and Red Hat collaboration, which is a fully autonomous boat that is going to basically circumnavigate the globe. And that's all powered by open source technologies.
That's fabulous. So we're going to go from self-driving cars to boats that navigate the world. And I'm hoping that there will actually be individual air drones that can actually get me from place to place without me driving at some point in time, assuming we go anywhere ever again. So that is where we are at this moment. I actually like where you were going with the computer vision use cases, and I think that actually tees Matt up quite nicely to talk about what we see as a real problem in terms of revenue leakage in retail. Matt, maybe you can walk us through how AI is being used in retail to prevent a really big problem that they're having today.
Absolutely. So we work on a very important problem in retail, physical retail or brick and mortar retail. It's actually $100 billion problem. It's about shrink, and shrink it also refers to inventory loss. And in particular, we work on scan fraud, which is a problem that occurs at the front end of stores at primarily self-checkout. And self-checkout machines have become, much more relevant these days, of course, due to COVID-19. But there's an increase in loss at self-checkout when compared to staff lanes, and a significant loss. And so what we do is, and the value we bring to retailers is that we actually use cameras overhead self-checkouts to basically detect scan fraud or accidental misscans. And how it works is that basically we're looking at the products, just the products as they move across the scan bed, and we look for several common issues. So, for example, misscans where a barcode is is just not scanned, it's covered, or it's just manipulated such that it's not scanned. We work on bottom of the basket where we observe that there's been products that haven't been they've been left in the shopping cart. But one of the really interesting ones is called ticket switching, where a product was scanned with a barcode that wasn't its original barcode, an inexpensive barcode that was either attached or was stacked with a product in front of it. And so how that works is we actually do product recognition. And so what's going on is that we're essentially pumping video into the back of the store on a server with NVIDIA EGX platform running. So the NVIDIA GPUs, primarily the T4 GPUs, where we have a variety of streams, maybe dozens of video streams coming in, and we're looking for these issues. But with product recognition, what's happening is we're actually learning at the same time as actually we're doing inferencing. So we're learning all the products in the store, and then we're verifying that a given scan, a given UPC actually matches the product that was actually scanned. And so how that works is that so typically in AI, you usually have to have like a side set of data that you're going to label and then train. But we've actually used a technique called weakly supervised learning, where we're actually basically having a self-learning system. And so it's a very elegant approach because it's very scalable. And once the system is deployed into stores, it starts to automatically learn the products and then apply the tech at the register. And so when an exception occurs, a staff member is alerted and can assist the customer to resolve the issue.
Excellent. That's a great use case that I think that everybody can actually relate to the concept of also how often do I need to train? How do I actually get accurate training data? Labeling has been a real issue for a lot of companies. So being able to automate some of that, I think, is a really interesting concept that we can take away from this. Jimmy, I want to circle back to you for a moment. When we think about what's going on with AI, we actually are getting better processing technology. We're getting better software toolkits, so to speak, to actually make the creation and management of models easier. But was it difficult for you to move from what you were doing to a new stack? Like, how is that process working? Like, if you were an organization, you were thinking, I want to make a change. This strikes me that this was an issue. Was it that you had something that was so much better to go to that you said, okay, let's do it this way. We really need to do it this way? Or how should companies think about that process?
Yes, I won't say it was easy, but it wasn't that difficult. So basically, the issue was to convince our people that this is the right way to go. And basically, as I already said, as BMW, we produce car. So that's the most important thing at BMW, is to bring the car to our customer in the cheapest way we can do it. But in the same quality and the better quality, because we are at the end of the day a premium car seller. Nevertheless, we need to implement new technology in order to optimize our processes and to support our people in the production to do their job easier and faster in order to produce more cars. As I already mentioned before, in the last 10 years, we already doubled the production amount of our cars and the sales of our cars, which is not making it easier for us. And just taking consideration that to produce every 56 seconds a car, you can imagine how important it is to make sure that the process is working perfectly, and our availability has to be over 99%. So basically, the most important thing is to bring our people inside of our plants and our logistic to learn the new processes and to bring their expertise in order to make sure that these processes will work in the future. At the end of the day, buying a final, buying a final product wouldn't be that easy, because we need to train our processes to recognize, for example, assets inside of BMW, which are specially designed and created for BMW. That means our people need to do the job by themselves at the first day, and they need to train our algorithm and models in the robots, for example, to recognize each pallet that we deliver to the production line in order to be able to automate the process. And at the end of the day, convincing these people wasn't easy, but I won't say it was so difficult, because we showed them the way that we are willing to take, and we showed them how the results could look in the future. And at the end of the day, we are supporting them to do their job better and faster and easier at the end of the day.
Excellent. So Jered, when we think about open source, a lot has changed in open source. And I think, we think more of open source as a platform now. Can we talk a little bit about how open source and AI are maybe coming together, and what organizations should be thinking about?
Yeah, so I think a lot of what's happening in AI as well as in edge computing is moving so rapidly that it's really important to choose open platforms, because that's where the collaboration is happening. That's where the innovation is happening in each of these components. You look at what's being built, everything's being built on Linux, everything's being built on Kubernetes, everything's being built on platforms like TensorFlow or Jupyter Notebooks. And all of these are open platforms, which means that everyone can bring their best technologies forward. Everyone can come with the technologies they want to integrate and be able to immediately plug them into this enormous ecosystem of AI components. And then rapidly connect them to applications. So, for example, we have a completely open project called Open Data Hub, it's not a product. This is simply a blueprint of how you can use open source components to all work together. And that works across different hardware platforms, different software platforms, and allows rapid innovation of new applications and new technologies.
Excellent. Matt, when we think a little bit about what's going on with retailers and what's going on with AI Edge, that data that we talked about and the collection of it and the training of it, does all that happen at the edge? Do we use the edge and the cloud in a combined status? How should organizations think about where and how to process this type of data?
Yeah, it's a great question, and it's actually, the edge is doing the heavy lifting. It's for a variety of reasons. First, it's also something back to what Jered was saying. You have so much video coming in, it's totally inefficient to process it elsewhere. You have to process it right then and there. So there's an efficiency argument, but also there's a privacy argument as well. So we're learning, and we're actually performing inferencing all right in the same spot, basically. So it's really important to do that. The other interesting thing about retail is that you have access to, when a store is actually running, there's just tremendous amounts of data. And so you want to leverage that and basically not get in the way. You don't want your application to kind of get in the way of the data. Let the data speak for itself. So if you had to, for example, collect data off-site, label it, and curate it and do all of that work, you're not really getting the full advantage of what's happening in the store, because actually what's really going on is that there's enough interaction between the customer and the self-checkout that you can actually learn directly without having human labelers intervening. That's actually the weakly supervised learning approach, or the self-learning approach that we're leveraging. So doing more at the edge brings just tremendous value. And again, it's at the end of the day, it's actually about scalability. Having a solution like this can work across thousands and thousands of stores.
Jimmy, where do you think you are in terms of the process? You talked about the ability to get to that 99% reliability, and having perceptual robots that can really zoom around a factory and do this all in real time is actually quite a feat. Are you 50% there, 75% there? And what would you like to see happen in the future?
It depends on which robots we are talking. So as I already mentioned, we are implementing 5 new robots to support our people in the logistics. Two of them are already productively working inside of our plants in 4 different plants in Germany. Two of them are piloting. We are piloting 2 of them right now, and the 5th one is already in proof of technology. So basically, it depends on which project we are talking about. But nevertheless, we are still at the start. I think at the end of the day, the technology, it's running very fast and we have to keep up. So basically, we need to train our people inside of our plants to keep up with this new technology. And for me, it would be amazing if we can see our robots working inside of our plants productively by the end of the next year.
Perfect. And then maybe Jered and Matt, very quickly as a wrap up, piece of advice for the audience. Jered, we'll start with you.
Absolutely. I think the important thing, especially when applying AI at the edge or AI in general, is just make sure you understand the problems that you're trying to solve. That AI can help you if you're not sure exactly how to solve them, but it can't figure out what it is you're trying to do in your business to begin with.
Sure. Excellent.
Yeah. So my advice is that to really appreciate the difference between a demo AI system and a mass production AI system. Making an AI system actually scalable is very, very different from actually just making it run. And that's sometimes a mirage that happens when people are starting to play with these technologies. Looking beyond just the canonical approaches, looking at research, we just had CVPR, for example, the top conference in computer vision. There's a lot of techniques out there that really break away from just the kind of, is it a hot dog or not?
Perfect. Jimmy, any closing thoughts on your side, given that you're deep in the middle of this?
No, I can assure what Matt said. It's the right thing to do, especially when it comes to production and especially when it comes to high availability. So it's not the same to run a demo or do a proof of technology and run it as a production. So it's basically a huge difference between these 2 stages.
Great. Well, thank you, gentlemen, for your time. It's been wonderful hearing your insight.
Thank you.
Thank you.